We'll be going through our properties of parallelograms in this video. So first, we are going to define what a parallelogram is, and it is a quadrilateral or four-sided figure in which both pairs of opposite sides are parallel and congruent. So remember, to show that sides are parallel, we mark the lines with the same number of these little arrow symbols. So we could say QP is parallel to RS. Remember, another way we showed that would be to say that these two segments are parallel like this. We would also say QR and PS are parallel. To show that sides are congruent, we mark them with the same number of tick marks. So QP is congruent to RS, and we would show it with that equal sign with the squiggly line. That means they have the same measure. QR and PS would also be congruent, but since they're not the same congruency as QP and RS, they get the 2 tick marks. Another property that we have in parallelograms, so the opposite angles are congruent. So angle P is congruent to angle R, and angle Q is congruent to angle S. In parallelograms, the adjacent angles are also supplementary. So what that means is the angle P plus the angle S must add up to that total of 180. So if I have the measure of angle P plus the measure of angle S, it will equal 180 degrees. Angle Q and angle R would be 180. Angle R and angle S would be 180. Any angles that are next to each other will always be supplementary. And finally, the last property that we have in a parallelogram is that the diagonals will always bisect each other. So remember, the diagonals are drawn from one vertex to another that are non-adjacent. So P is not adjacent to R, so we can connect them to draw a diagonal. And we have another diagonal from Q to S. That means that these two diagonals are bisecting each other because this is a parallelogram. So this center point up to Q would be congruent to the center point to S. And then same from P to the center point would be congruent to the center point over to R. So they're bisecting each other, which means they're cutting each other into 2 congruent pieces. All of those are the properties that make a parallelogram, and as long as you can prove at least one of them, then you know you have a parallelogram. So we're going to apply those and find these missing pieces. So if you want to pause the video and try it on your own, then you can come back to review when you're ready. So in each of these shapes, we are given that they are parallelograms, so we know that the opposite sides must be congruent. So in this first parallelogram, we know that x must equal 9 and y must equal 15. We also know that opposite angles in a parallelogram must be congruent, so 55 must equal A. The opposite sides in a parallelogram are always congruent, so in this one, n equals 12, and 6 will equal m plus 1, so we just have to solve that equation to get 5 equals m. And in our last quadrilateral, the opposite angles should be congruent, so 2p is equal to 120. We'll divide each side by 2, and that means that our p value is 60. That would make this angle down in the bottom worth 120 to make it congruent to its opposite angle. Again, if you'd like to pause and try these on your own first and then press play when you're ready, go ahead. So in each of these, again, we're using those properties that opposite angles are congruent and opposite sides are congruent. So 7 must equal 16 minus h. So to get the h by itself, we can subtract 16, which leaves us with negative 9 equals negative h. We would divide by negative 1 on each side, so we're left with 9 equals h. And to solve for our missing variable g, 65 must equal g plus 4. So we'll subtract 4 from each side, and we're left with g equals 61. Next up, we have our congruent sides that are opposite one another, so 20 equals z minus 8. We will add 8 to each side to get 28 equals z. And over here are congruent opposite angles, so 105 equals d minus 21. We'll add 21 to each side, and we're left with 126 equals d. On the next slide, when you are ready, you can press play, but go ahead and pause these to see if you can figure out the remaining missing variables in each of these parallelograms. So remember that in a parallelogram, the diagonals will always bisect each other. That means that they're cutting each other into 2 congruent pieces. So in our first quadrilateral, or our first parallelogram, 5y should be congruent to 4y plus 4, which means their lengths will be equal. We can set them equal to each other to solve for y. We'll subtract 4y from each side, which will leave us with y equals 4. Then in our other set of diagonals, 3x should be congruent to 12, so we can set them equal and divide each side by 3 to get x equals 4. So in both cases, for both of our variables, we ended up with a 4 here. In our next problem, 16 and 4m should be congruent pieces of their diagonals, so we're going to divide by 4 on each side, so m equals 4. And in our other set of diagonals, 9 minus n should equal 2n. We can add n to both sides, which gets us 9 equals 3n. If we divide by 3 on both sides, we see that n equals 3. Finally, we have 15 equals 5a because this set of diagonals and their segments should be congruent because they were bisected. We'll divide each side by 5, so 3 equals a. And then b minus 1 should equal 9 because those parts of the diagonals were bisected. We will add 1 to each side, so we're left with b equals 10. So once you know these variables, you can go back in and check to make sure. So like when I found that y was 4, that means that this diagonal should be worth 20. 4 times 4 is 16, plus another 4 gets us that 20. 3 times 4 makes 12. So we can see that those parts of the diagonals were all congruent to each other because they were bisecting one another. On our next slide, we're going to, again, use our parallelogram properties to find these missing angles, and you may have to use some other background knowledge from our parallel line angle pairs to figure out the rest of these. So I'll help you start off. We have angle AEB that we want to figure out, and that's this angle right here. Well, this angle is across these intersecting lines from the angle that is worth 117 degrees. So these two angles, remember, are vertical angles, which means the measure of angle AEB should also be 117 degrees. For the angle BAE, that's over here, we are trying to figure out what that is. And you can see that we have a triangle ABE sitting right inside of our parallelogram. Well, if this is a triangle inside of our shape, then we know that if we take 180 and subtract the two angles we know, which are 117 minus 23, then we can find what that missing angle is. So when we do that, we are left with a missing angle of 40, and that tells us that angle BAE will be worth 40 degrees. So now we can label that in our picture. That means that this entire angle DAB, even though we can't see it fully right there, is 120 because we're adding our 80 plus 40. So the angle that is across from it in the parallelogram should also be 120, and that might help us later. Then we're looking for angles ECD. So angle ECD is right down here. We know that it's adding together with 120, but we don't know anything else about it. So we're going to have to use some knowledge of our parallel line angle pairs. So remember that since this is a parallelogram, we know that the top and bottom segments are parallel to each other. So AB was parallel to DC. There is a transversal AC that is cutting through them, and we have this angle up here that was worth 40. That will be an alternate interior angle with the angle ECG that we're looking for. We know that between parallel lines, alternate interior angles are congruent, so this angle should also be worth 40 degrees because of alternate interior angles. And that was our theorem that said when the lines are parallel, alternate interior angles must be congruent. Finally, that leaves us with the angle EBC. I'm going to erase some of our writing so we can see where we're at. Angle EBC is up in the corner here. We want to know what this is. We've already figured out that this was 40, so this entire angle in our parallelogram was 120. Because this is a parallelogram, we know that angle B altogether should be supplementary with 120. So this entire angle, ABC, should be worth 60. And since we know that ABD is worth 23, we can take 60 minus 23, which gives us a difference of 37. So the measure of angle EBC would be 37 degrees. So we kind of have to use some new knowledge and old knowledge to apply to these problems and solve for the missing angles. If you think you're able to figure out the next one using those similar strategies, go ahead and pause and press play when you're ready to review. We can see that we are looking for angle 1, angle 2, 3, and 4 in this diagram. We are given that the angle STV, this corner angle, is worth 70 degrees. So if we know this entire angle is worth 70, then the measure of angle 1 would come from taking 70 minus 40, which leaves us with 30. So we have 30 degrees. For the angle 2, we can see that that is making up a triangle MTV, where we already know 40, 35, and then some angle. Well, since it's a triangle, we can take 180 minus 35 minus 40, and we're left with 105 degrees. That means that the measure of angle 2 is 105 degrees. For the measure of angle 3, we talked about how in a parallelogram, the consecutive or adjacent angles will be supplementary. So since angle STV is 70, then angle TVR must be worth a total of 110. So if this is 110 plus the 70, that means they're supplementary. We already knew that angle 2 was worth 105, so to find angle 3, we're just going to subtract 110 minus 105, which is a difference of 5. So the measure of angle 3 is only 5 degrees. And finally, we want the measure of angle 4, and this is where our parallel lines come in again. We have the line ST is parallel to the line RV. They are being there's a transversal RT going through them, so we would know that there are alternate interiors here and here. Well, that doesn't quite help us, so we might have to look at a different transversal and check our other parallel lines. So in a parallelogram, both sets of sides have to be parallel. So RS would be parallel to TV, and then RT is still a transversal here. That means that angle 4 is an alternate interior with angle RTV, which we knew was 40. Since they're alternate interior angles between parallel lines, then this should also be congruent at angle 40. So how can you prove that a quadrilateral is a parallelogram? As long as you can show one of these 6 things, then you are going to be able to prove that it's a parallelogram. So both pairs of opposite sides must be parallel, or both pairs of opposite sides must be congruent. You could show that both pairs of opposite angles are congruent, show that one pair of opposite sides are congruent and parallel. So notice how this one's kind of similar to the first and the second, but it's saying if you can show that one pair is both of those things, then you don't have to worry about the other set of sides at all. Your other way to show it is that if the diagonals are bisecting one another, or if one angle is supplementary to both of the consecutive angles, so those angles that are right next to each other in the parallelogram. So we're going to use the text box to decide which of these quadrilaterals are parallelograms, and you can explain your thinking in the text box, but we want to decide whether or not these will actually work. So in our first set, we have a shape where it's got 4 sides, and then we have one set of sides that are parallel. But that's not enough information for us to say, so this would be a no, that these are not a parallelogram because we don't have enough information. In B, we can see that the 2 pairs of opposite sides are congruent, which is enough information to say this is a parallelogram. In C, we're shown that the diagonals are bisecting, so we can show that these are a parallelogram. And then our last shape D, we have 64, 64, and 117. Well, if this is a parallelogram, then those consecutive angles should be supplementary. If we add up 117 plus 64, we actually get 181. So those are not supplementary, and this would not be a parallelogram. On the next slide, we can see that in shape A, the 2 sides that are opposite one another on the left and right there are parallel and congruent. So this would be a parallelogram because one set of opposite sides is both of those. On B, we have a parallel side and we have a congruent side, but we do not have enough information. That would either need to say 12 and parallel, or both sets of sides being parallel and both sets of sides being congruent. In C, we can see that both sets of sides are parallel, so that would be a parallelogram. And in D, our consecutive angles, 60 and 20, or 120, would make 180, and 120 and 60 again would make 180. So since the consecutive angles are supplementary, this would be a parallelogram. Here we need to prove that the shape is a parallelogram by showing that GK and HJ are congruent and that they are parallel. So in order to show that GK is congruent to HJ, we need to find the distance of each of these. Since it's on a coordinate plane, we're going to have to use the distance formula. So to find GK, we'll use the distance formula, which is y2 minus y1 squared plus x2 minus x1 squared. I've already labeled the points x, y that are in our shape. So for GK, we will do 4 minus 5 squared plus 3 minus negative 1 squared. This leaves us with negative 1 squared, which is 1, and 4 squared, which is 16. So that means that the length of GK is the square root of 17. So if it's congruent to HJ should have the same distance. So for HJ, using our distance formula, we have negative 5 minus negative 4 squared plus 1 minus negative 3 squared. Again, this leaves us with negative 1 squared, which is 1, and 4 squared, which is 16. So we do end up with that distance of the square root of 17. So since they're both the same length, these two sides are congruent, and we can show that now GK is congruent to HJ. Next up, we have to figure out, well, are they parallel? So remember we learned about how to tell when lines are parallel. Their slopes must be the same. So all we need to do is find the slope of GK and HJ. You could use the slope formula, or you can look for rise over run on your graph. So from G to K, I'm rising negative 1, and I'm running positive 4. So that means that the slope of GK will equal negative 1/4. The slope of HJ we can find the same way. We're rising negative 1 and we're running positive 4. So we're again left with a slope of negative 1/4. Since their slopes are the same, they must be parallel. So we have used the distance formula to show that they're congruent and found the slope of each to show that those have the same slope and they are parallel, which means that this must be a parallelogram. In our last problem, we are given 3 vertices of a parallelogram, and we need to give the coordinates of the 4th vertex. So because we have negative 1, 8 going to 4, 5, if we would like to draw a side that is parallel to this, we are going to have to mimic that same slope from this other vertex. So on negative 1, 8 down to 4, 5, we are moving 1, 2, 3 spaces down, so our rise is negative 3, and our run is going to be over by 5, so plus 5. So we need to repeat that over here. We're going to go down 3 and to the right 5. That means that I should end up here. But if this is truly a parallelogram, then that needs to work for my other line on my other side. So my other side slope is down 9 and to the right 2. So my other side should match. So down 9 and to the right 2, and I did end up in that same spot. So because I've checked the slope and both of those sides would have those parallel lines, that means that my 4th vertex should be down here at 6, negative 4 for my last vertex. And I've done that by finding the slope. You could also use the distance formula, but it might take a little bit longer. I think this will be the faster method for you to solve a problem like this. Thanks for watching.